Hi, welcome to question 7 of the 2023 paper 2 for the Leaving Cert ordinary level. So as always, if you want to copy the notes I'm working on, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. So question 7 here is like geometry. I'm sure there'll be trigonometry in here somewhere. So this, let's read through it. And there's a 10 marker for the first part here. It says Olga is a cyclist. She is measuring how long and how steep different roads are. So second I see steep, I think like slope, okay, rate of change. So there could be differentiation here. Now the diagram below shows a road AB. So this is AB, so it's at an incline. AC is horizontal, okay, so see there going across. And then BC is vertical, and that means they're at right angles to each other. It says the gradient of the road AB is given by the length of BC divided by the length of AC. Now, in coordinate geometry, this would just be the concept of the rise over the run, which is the rate of change. How fast is y going up for every jump of x? Okay. Now, we are told more information. It says the gradient of the road is written as BC over AC, written as a percentage, is a measure of how steep the road is. Lots of words. In parts A1 to A4, there are 4 different values for the length of AB and the length of AC, and 4 different gradients. This may be the same calculation over and over again. Find the gradient of the road AB when BC is equal to 24 and AC is equal to 135. So look, if in a question like this, if you're not sure what to do, like just do what it says. Okay, the length of BC we're told is 24, so it's 24 over the length of AC we're told is 135. Now we're told that it's a percentage, so to multiply to get a percentage, we always multiply by 100. Now this fraction is less than 1. Okay, the number on top is lower than the number on bottom, so this is going to be between 0 and 1. Multiply that by 100. I have it done out here from before, and I got 17.77, and it says to the nearest percent, so the 7 here is what matters. 5 or greater, the number prior to it rounds up by 1, and we get 18%. That's it. Now, part 2 says find AC when BC is equal to 16 meters and the gradient of the road AB is equal to 12%. Give your answer correct to the nearest meter. So look, we know the statement from the previous page, the BC over AC is equal to the gradient of AB. So you just rewrite that, like the length of BC over the length of AC, okay, is equal to AB percentage. Now, if you put any of the numbers in, so like 16 over AC is equal to 12%, you're flying, okay? Now, in the notes I've got it done out here, that's the same thing as what we've just said, except I've just reversed it. So the percentage of AB is equal to BC over AC. Now, I know that BC is 16 and AB is 12. That substitutes the numbers into place. That's where we left off on the previous page. And now we want to make sense of this. So remember, percentage can always be expressed as over 100. So 12% is the same thing as 12 over 100. Okay. Now we want to get rid of the 100 here. Okay. So there's different ways of doing it. So I'm just going to multiply the top here by 100. Okay. If I do it to one side, I have to do it to the other. Now I've created calculations I need to just resolve. Okay. So the 100 and the 100 will cancel because that's why I did it. And on the far side, the 100 by 16 is 1600. So I'm left with a slightly simpler statement. Now, I don't want the AC. I want to know what this is. Okay, and I could maybe start guessing what 1600 divided by what number gives 12. Now, it won't be easy to get, but technically possible. But I might use my algebra. If I want to get rid of something on the bottom of like a fraction, I can multiply the top by it. Okay. Now, if I do it to one side, I have to do it to the other. Now, when I do that, okay, these two things cancel, even though they don't look like it the way I presented that. This is on top. So some on top and bottom will cancel, and you're left with this statement. Okay, they cancel. Then you're left with 12 times AC is equal to 1600. Now, I want to get rid of this 12, so I could I'm multiplying on the left and I ran out of space, so I just did it the fast way. If I'm multiplying by something on the left, I can move it across the far side as long as it does the opposite operation on the far side. Now, or I could just divide both sides by 12, which is maybe the more fundamental way. The 12s here will cancel, and you're left with AC is equal to 1600 over 12. Now, in the calculator, that will evaluate out to be 133.33, and we're asked to leave our answer correct to the nearest meter. That's 133 meters. And that's it. Okay, it's a lot of algebra there, but look, it depends how you do your algebra. As long as you're being consistent, and you're going to be fine. The way I do it here is maybe a bit long-winded for like the way it's often taught, purely for speed. Now, part 3 says use the theorem of Pythagoras. So straight away, I'm not even going to ask. I'm going to write it down. Now it's in the maths tables. Okay, although arguably we should all know Pythagoras' theorem in Leavens Cert maths, but I totally understand that this may not be something that is memorable. It was literally drilled into me in my educational journey. So it says use the theorem of Pythagoras to find AC when BC is equal to 27 and AB is equal to 105. So look, we know what the diagram looks like. So look, let's draw it. So BC was this length here, and I should double check that. Okay, and the AB is 105. Now this is my right angle, even though my diagram doesn't look like it. I swear I'm not drunk. So this is a right angle. So that means this is the hypotenuse, or you can call that the value of C. I'm sure on the next page I have it done out. So it's the same thing, I've kind of just done it. Oh wait, bloody hell. Let me go back and check if I messed up. Okay. Damn it. Oh, AB is, okay, I did mess up. So it says here AB is 105, that's up the hypotenuse. The side here is 27. So it's not going to be as straightforward as we might like, okay, but it's still doable. So it's still Pythagoras' theorem, except I know the C value. Now I'm going to call this long section here that I don't know the A value, and then the V value is the other side, which I was told is 27. So there's 3 unknowns in the formula. I know 2 of the 3, therefore it is solvable. It's just a matter of substituting the numbers in. Now instead of the C, I put the 105 in brackets. Instead the A, I don't know what it is, so I might as well stay using A. I could use X, whatever. And on the last one there, 27 in place of B, and that's to be squared. Now, I've evaluated the powers. You don't have to. You could move them around as a power if you wanted to, if you're comfortable doing that. But if you want to evaluate them out, that is a correct step. Just make sure you program the calculator right. And if it's a negative number, always make sure to put it in brackets. But these aren't negative because they're lengths. But now on the right hand side, I realized that I want to get rid of this 729. Now, the simplest way to get rid of something is to take that number away from it. Now, if I do it to one side, I have to do the same thing to the far side. So I didn't have any sheet calculations I need to evaluate. Like the 729, take away the 729 will cancel. And on the far side here, 11,025, take away 729, I got 10,296. Now, the thing I often see people forgetting here is that on the far side, this was A squared. Like this 10296 is not your answer. But if you were using like your, I suppose, BS meter, like this A would have to be less than 105 because the longest side in a right angle triangle is always the hypotenuse. So if the hypotenuse is 105, well, this side has to be less than it. So that might trigger if you were making a mistake. And one way to avoid making a mistake is to always write down like everything that's on both sides so you don't forget something. Now, I'm going to look at the A squared here and realize that I want to get rid of the power. Now, the simplest way to get rid of something is to do the opposite to it. Like, for example, just above, we got rid of the 729 by doing the opposite to it. So if I want to get rid of a square, I could square root it. That'll do it. Okay, they'll cancel. Now, if I do something to one side, I have to do the same thing to everything on the far side. So the square and the square root cancel. You're left with A. On the far side, the square root of 10,296, I came up with 101.4. And I'm just double checking against the marking scheme. That's cool. It asks it for to the nearest whole number. So 4 or less, the number prior to it stays the same. So it stays at 101. It's meters because it's a length, and that's the answer.